Now we'll just take a look at some examples that kind of combine a little bit of all the properties that we've learned in this unit or this lesson. So go ahead and take the opportunity to try these on your own first. You'll benefit more from the demonstration if you've taken a look at them and given them a try. So if we look at sample problem number 4, part A, we have both numerics and variables in there. And the easiest thing to do initially is just to break these apart as many ways as we can. And so I'm going to start by breaking up the numerical values from the actual variables. So I'm going to have the cubed root of 125 times the cubed root of y to the sixth. Now the cubed root of 125 is just simply 5. However, basically I have two sets of 3's underneath the radical, so I can actually break the y to the sixth up and try to get it down into 3's or powers of 3. And so what I'm going to do is I'm actually going to take the cube root of y to the 3 and then the cube root of y to the third power again. And so the y to the 6 is broken up into 2 y to the thirds. And this allows me to use the cube root and break it up twice. Now, that's going to give me y, that's going to give me y, and of course I had 5 out here, so I just need to combine all this back together again, and that's going to give me 5y squared as our final simplified answer. Now, if you are catching on to this, you may notice that I have twice as many y value powers as I have roots, so you can see how that translates into y squared. And so if you're starting to feel confident about your understanding of simplifying radicals, you may skip those steps and bring it straight to the y squared. But I would definitely get a feel for the simplification of radicals before you start trying to skip too many steps. Alright, let's look at part B. In part B, we have a fraction underneath the radical here, and there's a couple different ways that we can deal with this, and you can choose what best fits you. The simplest thing for me to do initially is just to break up the radical into two separate radicals. Now you can see on top we have the fourth root and a fourth power, so those cancel each other out directly. Now on the bottom we have the fourth root and we have y to the eighth, which is very similar to what we had in the previous example, where we have twice as many y values as we have roots. And so that is going to lead me to simply y squared. And if you don't remember how we did that, we basically would break this up into y to the fourth and y to the fourth, giving us y times y, and that's going to give us the y squared. So that will be our final simplified answer in that case. Okay, let's move on to the next one, and this is the one that usually really gets people worked up. Example C has a whole lot of things going on here. And again, what I'm going to suggest to you is we have numeric values and we have variables, and we have multiple variables. So I'm going to suggest that you break up the radical into all the individual parts. So what I'm going to do is I'm going to break it up into all the individual parts, simplify them each individually like they're individual problems, and then bring them back together at the end. So I'll start with the fifth root of 5 times the fifth root of a to the fifth power times the fifth root of b to the ninth power and the fifth root of c to the 13th power. Okay, and so we'll get started here with simply the fifth root of 5 can't be simplified. So we just are going to carry that down every single step. For the fifth root of a to the fifth, the powers cancel each other out, leaving us simply a. Now we have b to the ninth power. What's going to happen here is I can break this up into b to the fifth, and what will be left over is b to the fourth. And I wanted to at least get one of those b to the fifths out of there, because that'll allow one of them to cancel out, leaving me b here, but that's going to leave me b to the fourth under the radical. And basically what we're saying is we don't have enough of the power of b to be offset by the root of 5, so we just have to leave it underneath the radical at this point. Same thing with the c to the 13th. I want to break this up into as many multiples of 5 as I can. So I have c to the 5th, c to the 5th, and that's going to leave me 3 of them. So you can see 5 plus 5 plus 3 gives me the 13. And then out of this, I'm going to end up with c and c, but I have c to the 3rd remaining underneath there because I don't have enough to offset the root of 5. And so what we need to do now at this point is we need to take everything that is outside of a radical that we've simplified, and we need to put all of that back together. So that's a times b, and I have c squared. The next thing I need to do is I need to take everything that's inside a radical, and assuming in this case they are, that they are radicals with the same roots, then I can put those back together. If some of them had different root values, you would not be able to put them back together, but this is going to be the 5th root of 5 b to the 4th c to the 3rd. Now, let me give you a little fair warning here. I used 2 different colors so that you could see the difference of being out of the radical or inside the radical. This is all one answer. That's the simplified answer. However, if you're not careful, you can see here where you have c squared and the 5th root, it starts to look like a 25 a little bit. So you want to be careful how you write this to make sure that you don't get the 2 and the 5 kind of put together. You can also use a multiplication symbol between those if that helps. But just kind of keep the power of 2 and the root of 5 separated a little bit. And then finally, the last one is just a simplification problem, except this time we have a radical that has a variable in it. And so this doesn't change. These are still considered like terms, and this ends up actually being a very easy problem just by adding the coefficients. Alright, and there's your examples of some more challenging simplification problems with dealing with radicals.